The limit of a function is basically, suppose it is denoted by this thing extending to a. So when this is our number line here, suppose the a lies, so this is our function say. So when you are approaching towards a from both the sides, if it is the functional value approaches to the same point, then we say that limit of that function exists, and that point is basically the limit of this function at extending to a. Okay, so two things here is very important. We have to approach from both the side. So when we are approaching from the right side of a, that means limit extending to a plus fx. So a plus means we are approaching from the right side of x, right? So this is one thing. This is right hand limit, and left hand limit is fx extending to a minus. Okay, let me give you an example, then it will be clear. Suppose I have a function, that floor function we take here, because this will give you a perfect example of this thing. So suppose I am considering extending to 0, limit extending to 0 fx. So what is this limit? So what we have to do, we have to approach to 0 from the right side first. So can somebody tell me what is this limit?
0, sir.
Why?
Sir.
Why?
Because floor only takes value less than it, integer value.
So when I am approaching towards 0, this is
From the
0,
right side, that is taking
from the
only
right
0.
side. Yeah, so from 0 to 1, you can say open 1, all the values are 0. This is basically a constant function 0 in this interval. So in this neighborhood, when I am approaching towards 0, all these points are functional values are 0. So this limit is nothing but 0. Is it clear?
Yes, sir.
Everyone, is it clear? If anyone has a
Yes.
doubt in this point, please ask me.
Clear, sir.
Okay. Now, what is the left limit of this? Limit extending to 0 minus floor x?
Minus
Minus
one.
Minus 1.
Minus 1. Exactly. How can you calculate it? The same thing, right? When we are
Because it is coming from the left.
Yeah.
So lowest value.
Exactly. It will take the lowest value, that is minus 1. So you can see that left hand limit and right hand limit does not match, right? So when this kind of situation happens, we say that limit does not exist. Clear? If these two limits are same, if left hand limit and right hand limit are equal, then we say that limit exists, and we then denote it by limit extending to a fx. Okay, so let me give you another example. So suppose I am taking this function. If x is greater than equal to 0 and if x is strictly less than 0. So can you tell me what are the, if I want to calculate limit extending to 0 fx, what will be the limit? Yeah, what will be the right hand limit?
1.
Which function, which piece you consider for right hand limit?
The upper one, x square plus 1.
Exactly, because in that portion, when we are approaching from the right side, x is positive, right?
Yes.
So the upper portion, it is taking this value, so x tending to 0 plus x square plus 1, and you know that this is a polynomial function. So when we are approaching towards 0, it is nothing but 0 plus 1, it will give us 1. And
Yes.
what is left hand limit?
It is also 1.
Yeah, and in this time we have to consider this function, right?
Yes, sir.
Okay.
So can I ask why is it 1 on both the sides? Like if any number is positive, then maybe if we multiplied, there is some constant. Okay, but we are approaching 0. Okay, sir.
We are
Got
going
it.
towards 0, right? So
Yes.
whatever the number you are getting for each x, that will come closer and closer to 0 for x square.
Okay.
Then x square plus 1 will come to 1, right?
Okay. Yes.
Yeah. Okay. So here you can see that left hand limit and right hand limit are equal. So it means this function, this limit is nothing but 1. This limit exists and it is 1. So now my question is it always necessary that, so yeah, in this case, you know what is f of 0? F of 0 is also 1, right? Because it's defined in such a way. So is it always necessary that the if limit exists, then the value of that function is same as that limit?
No,
No, sir.
Why?
it could be discontinuous.
So for example, -1, it will be.
Maybe it is not defined at that point.
Which one? I just missed your
It may be undefined, not defined in that value in the domain.
suppose there is a suppose it is defined, then what happens?
Suppose if it is defined, if it is of a different value, then it is discontinuous again.
Exactly. Suppose it is defined also. So suppose we define this in the same function, what we have taken. So for suppose I am just deleting this. So it is for strictly again, and for 0 I am defining it as 0. I can do it, right? So this is also one function, right? But this function is discontinuous at 0 because the limit exists, although the limit exists and the limiting value is 1, but here f of 0 is not 1, here f of 0 is 0. So the limiting value at that point is not matching with f of 0. So there is a jump at that point, right? So how this will look like for the function? The function at x equal to 0, from the left hand side it is going towards 1, from the right hand side is going towards 1, but at 0 the function value is 0. So at this point there is a discontinuity. Okay, is it clear?
Yes, sir.
Yeah.
Will you
So
please
same
repeat
thing
that?
you can look for.
Hello, sir.
Yeah.
Please repeat that part, x less than 0 above.
So
this one, x less than 0.
So when we are approaching from the right side, the limiting value is 1. That you get, right?
Yes.
Yeah. Similarly for the left side, this is also 1. Now I am defining at x equal to 0, the value of the function we are defining to be 0. Okay. Suppose this is my definition of the function for x greater than 0.
It is defined.
It is defined in that way. X equal to 0, the functional value is defined as 0.
But if it defined as a 1, then it is continuous.
Yeah, if it is defined as 1, then it is continuous.
Okay.
Exactly.
Okay.
So it is depend exactly on the definition of the function.
Correct. Got it.
Yeah.
Got it.
So for continuity, you have to check 2 points. One is the limit at that point exists or not. It exists or not. This is the first checking you have to do. If it does not exist, then you can easily say that function is not continuous at that point. Okay. And the second thing is the limit should be same as the value of the function at that point. So if these two satisfied, that means the first condition means limit exists and the limiting value is same as the functional value at that point, then only we can say the function is continuous at this point. Okay. Is it clear?
Yes, sir.
Okay. So just a simple question, is floor x continuous? Is this continuous at x equal to 1?
No, sir.
No, sir.
Because why?
There is a step at x is equal to 1.
LHL left hand limit will be 0.
Left hand limit will be 0 and right hand limit will be 1. So limit does not exist that point.
Yeah.
So the first condition itself is not satisfied. Right?
Yes.
So we can directly say that it is not continuous. But if I change this question, is floor x continuous at x equal to 1.5?
Yes, it will be.
Yes, sir.
Why?
Left hand limit
Both
is equal to right hand limit.
And what is both the limits? And what is the
1. Sir.
1, exactly. So in the interval, what I was saying, yeah, exactly. What I was saying, in the interval a comma a plus 1, the function behaves like a constant function, right? So here it is nothing but 1. So in that interval, and at x equal to 1.5, the value of the function is also 1, right? So both the conditions satisfied. So at x equal to 1.5, this function is continuous. Is it clear?
Yeah. What if the floor is x plus 1 by 2?
X plus 1 by 2. Okay, let's come to that.
That it will reverse, right? Or will it?
You are asking this thing, right?
Yes. Yeah. No. 1 by 2 separate, not.
Oh, x plus 1 by 2.
Yeah.
Okay. Okay, this function. Yeah. So yeah, how the graph look like? At first, tell me
The
that.
floor will still be x, right? So
Okay. So what is f of half? What is f of
1. 1.
f of half is 1? Okay. In general, when we are talking about only floor of x, what is f of half? F of half is 0, right? So you
Yeah.
can see that there is some shift, right?
Shift
So basically
upward.
Shift of half.
those steps which we have seen for the step function, those will shift by half. So yeah, so minus half to half, like this. Now it is from half to 3 by 2. It is for 3 by 2 to 5 by 2, like this.
So now in this graph, it will be continuous at natural numbers, right?
Now it is continuous at natural number. Now it is discontinuous at 1 by 2, 3 by 2, 5 by 2, all these points. Right? Is it clear?
Yes, sir.
Sir, I didn't understand this.
Okay. So floor function you have understood, right?
Yes.
Okay. Now if I take this example, x plus half. Okay.
Yes.
So what is the value f of 0? Can you tell me?
Half.
No, this is floor of half. What is floor of half?
0.
0.
Yeah, 0. And so you can see that this is basically shift to. So what is f of half? Can you tell me what is f of half?
That way floor of 1 is 1.
Exactly, that will be 1. So whenever the number of this, so how floor is defined, let's recall that. So it is defined as a if x is in between a and a plus 1, right? It was defined like this way, floor function, the original floor function, fx equal to floor x. Now we are taking fx equal to floor x plus 1 by 2. Now it will be giving the same thing, x plus 1 by 2, when x plus 1 by 2 in between a plus a, this thing, right? So when x is in between a minus half to a plus half, in this interval, then only the functional value will be a. Is it clear?
Yes, sir.
Yeah, who was asking me? I mean, is it clear to you?
Sir, actually, I wasn't able to understand the plot that you have made now of the floor function. Did you make it for the new function?
Yeah, I have made it for the new function. So
What will be the
in this new
markings?
case, yeah, in
Yes,
this
sir.
new case, for minus half to half, this is minus half to half. For this interval, you can check that this floor function is giving the value 0, right?
Right.
And for half, it is giving the value 1, and for half, from half to 3 by 2, it is giving the value 1. Okay?
Sir, 3 by 2 plus half will be 2.
I mean
and
3
a
by 2
floor
open,
of
3 by
2.
2 open, sorry, 3 by 2 open. This half is also open here.
Okay.
So what is f of 1? F of 1 is floor of 3 by 2, right? That is 1. So here it will be somewhere. Okay? So
Right.
whenever x is in between half to 3 by, basically I am shifting the floor function by half on x-axis. Okay?
Yes, sir. Yes.
Is it clear?
Yes, sir.
So for 3 by 2 to 5 by 2, again the floor function will be 2. 5 by 2 is not included. Till we reach 5 by 2, the floor function will be 2. Okay?
Yes, sir.
because if you take 3 by 2 plus half, that will give you 2. So from 3 by 2 till before 5 by 2, we will get the same value, right?
Yes, sir.
Is it clear now?
Yes, sir.
Okay.
So same function, if let's say the plus half was outside the floor, then it will move vertically, not on x-axis.
Then it will move vertically. Yeah, let me show you graphically. I think it will be better. So, yeah. Floor of, I'm considering x plus half first. Okay. Yeah. So can you see?
Yes, sir.
From here, from 0.5 minus 0.5 to 0.5, it is 0. From half to 3 by 2, that is 1 by 5, that is 1. Okay. So original floor function was like this. So this is the original floor function. You can see that, right? This is the original floor function. In between 0 and 1, the value is 0. In between 1 and 2, value is 1, like this. But when we are taking this value, x plus half, yeah, we just shifting left to half. Okay, is it clear?
Yes, sir.
Okay. And if I take this half outside, somebody has mentioned it. Yeah. So we are basically shifting vertically to 0.5, right? So in between 0 and 1, the functional value will be half now. In between 1 and 2, the functional value will be 1 by 5 now instead of 1. Okay. Is it clear? So this is the original floor function and this is the new floor function. So you can see the shift will be vertically half unit. Okay.
Yes, sir.
Okay, so I think this is clear, right? So let me give you another example to check the continuity of a function. This is one famous example. Yeah. So sin x by x, you can see that sin x by x is not defined at x equal to 0. So for x equal to 0, I have defined it separately. For x equal to 0, I am taking the value 0. So is this function continuous?
No, sir.
Why?
Yes. Yes.
The limit
Okay.
at 0
There are
is 1.
two kind of response.
For all others, it's 1. For 0, it's 0.
For 0, it's 0, yeah.
For all others, it's only 1.
The left limit and right limit is 1, but at 0, it is 0.
At 0, it's 0. Yes.
Exactly. So the left limit and right limit is 1 because we already know this is a important type of limit we have already seen. Also have seen the proof of this. So this is nothing but 1. So this limit exists and left limit and right limit are same. So that's why this limit exists and this limit is 1. But it does not matches with f of 0 here, right? So it is not continuous at x equal to 0. Is it clear? Is it clear?
Yes.
Yeah.
Yes.
Yes, sir.
Yes, sir.
So what can we define f of 0 so that to make it continuous?
1.
1.
Yeah, if we want to make this function continuous, we should define x0 equal to 1. If we define that, then the function is continuous. Is it clear?
Sir,
Yes.
I have a doubt.
Yes.
Yeah,
They
sure.
did give a detailed proof for why sin x by x is 1, but I
That
want to
proof
ask.
actually is not required. I mean, yeah, tell me.
No, I think it was proven. It's one of the videos.
Yeah,
one of
it
the
was
video,
proven, but by direct substitution you get 0 by 0. Why is it that we always choose to further pursue indeterminate forms?
Acha, matlab, you are asking that why are not we using L'Hopital's rule, right? Is that your question?
No, my question is, if we do get something like 0 by 0 or infinity by infinity, why do we further go on and try to, rationalize it or look for a, normal number value? So
Okay.
Hmm.
Okay, I think I got your question. Okay, so when the function is in 0 by 0 form or infinity by infinity form, that does not mean that function is, I mean, we cannot find the limit of that function. That is not the case. Okay, there in some cases their limit can exist. Okay, now if we want to find the limit of that function, we have to go to indeterminate form and using L'Hopital's rule to solve it. If you can see this graph of sin x by x, if I can show you this graph. Okay. Yeah. Can you see the graph of this function?
Yes, sir. Yes,
yeah.
sir.
So this is the sin x by x graph. Okay. So as you can see, when we are approaching towards 0, the value is approaching towards 1 from the both the sides. Okay. Although
Yes,
this is 0 by 0 form, but there is a limiting value. I mean, there is a point to which the value of the function approaches to. That means the limit exists, right?
Yes, sir.
Now, how can we calculate this limit algebraically? That is the question. Whether it is in indeterminate form, although it is in indeterminate form, we want to calculate the value of the limit, because we know that limit exists here by seeing the graph of this function. Okay. Now we want to calculate the limit algebraically. That's why the indeterminate form and L'Hopital rule comes in the picture. Okay.
Okay. Okay, sir. And it can also happen that it is indeterminate and limit does not exist.
Yeah, it can happen. Definitely.
Okay,
It can
sir.
happen.
So,
Yeah.
so can we basically say that the limit of a function is that where the function wants to go, and evaluation of a function is where it is actually, I mean, you put the value and what the function is at that value.
Yeah. Limit
So,
means approaching to that point. It
yeah,
may
where
not
it
reach
wants
that
to
point.
go. Yeah.
What is the value of function at close to that point, basically?
Okay.
Not value of that function. What is the value of the function it approaches to?
Approaches. Yeah, where it wants to go.
Yeah, it is not the evaluation at that point. We are not evaluating at that point, right?
Got it.
Yeah.
So
Okay.
just one small question, sir. Since if this type of problem comes in exam, this time what they said, we have to do it in pen and paper, and we have to solve it in our paper. So do we, if this problem comes, do we need to show that limit extends to 0 sin x by x is equal to 1 by full proofing?
No. This is standard thing. This limit is a standard one. You don't need to prove it in the exam. Okay. This limit, the sin x by x, limit extending to 0, this is standard proof. You don't.
In other words, proof requiring stuff will never be asked. Correct?
No. Yeah. Anyway, in this course, only MCQ, MSQ, and numerical types are there, right? So definitely in this course, it will not be asked. And even in some other courses where there are written exams going on, in that case also, this type of proof will not come. Okay.
Okay.
Sir, also if I may, I tried to search about these trigonometric identities because I felt there are a lot of them used. So I actually found a lot of them. So can we just get some of these identities?
So yeah, you are post-up, right?
Yes, sir, post-up.
So at the beginning, I was saying that we don't actually using those equalities. Whenever we require some formula, we will give you as a hint. Okay, you just remember the definition of sine cos tan and how the function behaves. Only these specific types of function here you can see, and then you can remember how these values of the function behaves with the angles. I mean, if the angles is between 0 and 90, then it is positive. All of them are positive. In between 90 and 180, then only sine is positive. This thing you can remember. You should remember the reciprocal of the function, and further you can remember sine 2x and cos 2x. This will be enough.
Okay, sir. Sorry, I actually could not join at the beginning.
Definitely. Okay, no problem. And if there are other formulas which will be required, we will give you as hint. You don't have to remember all this. Okay.
Okay, thank you, sir.
Okay.
Excuse me, Subodh, sir.
Yeah.
Sir, as far as I remember, in term one, before the final exams, we were given a problem-solving tips. That document it was created by Rahul sir. Sir, is it possible to compile a similar document for us in this term as well?
So basically, the plan is this week we are not releasing any new content, and we are releasing a recollection of basically a recall of all this concept of week 1, and do some problem-solving videos, and also give you an assignment of problems to solve it. Okay. So, and you want some problem solving tips. Tip means all these formulas are written, something like that, right?
Yes, sir. Yes, sir. Like similar to what was given during term 1.
So, is not that solve with us assignment enough? I mean, there are key points for each lecture, right? In solve with us assignment, you can, if you can see it in portal, you can see that those they are before every problem. I mean, every 2-3 problems, there are some key points. Those are basically all the problem solving exercises and problem solving tips, you can say.
Yeah, those are helpful, but it's a request that please provide this PDF of the assignments also. Otherwise, every time we have to log into the portal.
Okay. So yeah, definitely will.
I think solution you can download, I guess.
Provide the PDF. Yeah, sure.
The solution we can, but unsolved also it gets easier during revision. Otherwise, the solution is in front of you. So.
Okay. Yeah, sure. We will definitely give the PDF of all the assignments. Yeah. So this week, I think we will upload this. Okay. Okay. So till this point is okay, right? Till continuity, this is okay, right? Now,
sir,
yeah.
I mean, while telling that if a function is continuous at a point, you said that it need to be, I mean, the left hand limit and the right hand limit needs to be equal.
Yeah.
And the second point was that f of x equal to f of a at limit x tends to a, right?
Yeah, exactly. Yeah, these 2 points. Yeah.
Yeah. So I mean, in that function, in this function only, in that x square plus 1, x cube plus 1, how is this second point contradicting? Means, I mean, theoretically how it is contradicting. Can you show that? I mean, I understood how graphically it is happening. I understood that.
Okay.
But theoretically, I mean, I am facing some difficulties to understand.
Okay. So observe that. So right hand limit and left hand limit both are 1. This is clear, right?
Yeah, that is clear.
Yeah. So as we are approaching to 0 from left side or right side, we are approaching to 1. Yeah. But at f equal to 0, this function is strictly defined as 0, not as 1. So at point, I mean at that point, 0, 1, there is a gap in the curve. Because at 0, the functional value is 0. So there is a drop at that point, you can say. So at that point, the functional value does not matches with the limiting point. Okay. So if you just zoom into that picture, exactly at 0, you can see a gap. I mean, it's difficult to visualize that, I can see, but that is the case here. I mean, there is a gap at that point. Okay.
If these are given, you can use the properties of convergent sequences and evaluate these options. So here the first one is log 1 plus x and sin x. So we have a term from this second sequence and a term from the first one. So what we can do is we can try to connect those two. So log of 1 plus x by x is what we know. So and then divided by sin x by x. So basically you can divide by x and this gets cancelled and you get the original sequence. So now we can evaluate these. So to find the limit of this, you just need to find the limit of this divided by the limit of this. Because for sequences, you know f by g, then you can write it as limit f by limit g. And then for these two, you already know the limits.
Ma'am, thank you so much. I understood the theory behind this, but could you please explain option number 4, that sin 5x?
Sure. Okay. So basically, this is what you are doing in all the options in this problem. So since option number 4 has been asked, I'll explain that. So you know that limit of sin x by x is equal to 1 as x tends to 0. So in the fourth option, we have sin 5x, and in the denominator we have an x. But do we also know that limit as x tends to 0, sin 5x by 5x is equal to 1? Is this clear?
Yes, I got it.
Yeah.
Okay, so we multiply and divide by 5.
Yeah. If you
Okay,
have a 5 in the denominator, we are done. So for that, we multiply and divide. That's exactly the same way we do every
Ma'am, this option number 1 and option number 2, is it different?
Option 2 is not right. Option 1 is right.
No, it is same thing. Is it 1 minus x?
No. Both the options are the same function. One option says that the limit is not defined, but we have actually shown that the limit is equal to 1. So option number 1 is correct and option number 2 is not correct. That's it. It's the same function. Similarly, option 3 and option 4 are the same function, just that the correct limit is option number 4. In fact, option 5 is also same as these. And 6, 7, 8 are all same. The correct limit is 1 by 4. Here again, you will have to basically do all this kind of substitution and all that. For continuity, again, the left hand and right hand limits should be equal. Okay, so the limit will exist if the left hand limit and the right hand limit are equal, and the number that you get should be equal, both left hand and right hand limit. The function is continuous if it is equal to f of a, the value of the function at that point. So is it clear the difference between existence of limit at the point and continuity at the point? So for the existence of the limit at the point, the left hand and the right hand limit should be equal. That's it. It can be any number, but for the function to be continuous at that point, that limit should be equal to the value of the function at that point. It should be equal to f of a. Yeah, with respect to sequences, you can tell that f is continuous if and only if f of any sequence. So you can take any sequence an that converges to a, and f of that sequence should be equal to f of a. If this happens, then again f is continuous. Yeah, and you must have seen the sandwich principle. To evaluate certain limits of some difficult functions, you will evaluate limits of easier functions and try to squeeze it between two functions that you know. So if there are two functions f and g such that f of x is less than or equal to h of x less than or equal to g of x, and limit of f and g as x tends to a are equal, then the limit of the one that is being squeezed is also equal to L. So you would have already applied sandwich theorem in many examples. So yeah, let f be defined as x squared plus 1. Is this function continuous?
Yes.
Yeah, it's simple, right? Like you can just treat it as two different functions. X squared is a continuous function because it's a polynomial function. Okay, x squared plus 1 as such can be treated as a polynomial function. Anyway, all this sum, difference and all that applies to continuous functions as well. Yeah, so here in this problem, you're given a graph of a function. You have the function is not explicitly given, like f of x is equal to x squared plus 1 or things like that. It's not explicitly given. So looking at the graph of the function, it's very obvious, right? If the function is continuous or not. Because if there is a split, if you can draw the graph of the function without taking the pen out of the paper, it means that it is continuous, correct?
Yes, ma'am.
Yeah, so obviously this function is not continuous at 2 because the value, like there is a split in the graph. Similarly at 4, again, it is not continuous, but in other places it is continuous. Okay, so yeah.
The limit exists.
In this, yes, in this
not
graph, limit also does not exist, right?
Yeah, the limit at these points do not exist because the left hand limit is 10 here and the right hand limit is 2 here. So the limit also doesn't exist.
Okay.
let alone being equal to f of a, the limit itself does not exist because the left hand and right hand limits are different. So if it's equal to f of a or not, you can tell only when you have the definition of the function. Because if suppose f of a is given such that, okay, in this case you cannot tell because left hand and right hand limits are not equal. Okay, fine. Let us not get into that here. So here the left hand and right hand limits are not equal. Both exist but are not equal. So the limit does not exist, and hence we cannot talk about continuity here. And why I put this example here is because just by looking at the graph, you can tell whether it's continuous or not. Just the literal sense that it is not continuous. Yeah, here you have f of x.
If in the question asked that we have only left hand limit exist or right hand limit exists, so there are chances that these type of question will also come.
Yeah.
So we can say that the left hand limit and right hand limit exist, but at that point the limit doesn't exist and it is not continuous also at that point.
Yeah, just like someone told me a question, no, this mod x squared minus from the mock paper. Yeah, this problem.
Okay.
Here both the left hand and right hand limit exist, but they are not equal.
Yeah.
Yeah.
Thank you.
Yeah. Yeah. So now we have f of x is equal to this, yeah. So now tell me if you can talk about continuity here. Can you solve this problem, or is there any difficulty in solving such problems? This can be just simplified, right? Like x into x squared minus 9 by x into x minus 3. So x cancel out. X plus 3 into x minus 3 by x minus 3. Again, these two terms cancel out. So this is basically x plus 3. Is this function continuous or not?
Continuous.
Ma'am, at point 3, it's not continuous, right?
Yeah.
Equal to 3.
So x plus 3 is just a polynomial function. So as such, this is continuous, but it is for all values not equal to 0 and 3. So at 0, they have given one value, and at 3, they have given another value. So you need to check if at those 2 points, the limits are working fine or not. So as x tends to 0, what happens? The limit becomes equal to 3, right? This tends to 3 as x tends to 0. And this 3 is nothing but f of 0. That is how it is defined. So it is continuous at 0. And this tends to 3 plus 3, 6 as x tends to 3. Correct?
Yes.
The limit exists, but that is not equal to f of 3. So it is not continuous at 3. That is why this option is given. F is discontinuous only at one point, that is x is equal to 3. Similarly, you can do g of x also, right? So mod x is continuous. Correct? And this is the floor function, right? The floor function, it's not continuous at, the graph is something like this, right?
Please explain that mod part.
Mod function is like this. So this is continuous, there is no problem here. For the floor function, there is discontinuity at all the natural numbers, correct? At all the integers, basically.
But ma'am, that mod is at x less or equal to 2. No?
Yeah. So what? It doesn't matter, right? Like for x less than or equal to 2, it is mod x. Mod x is basically like this, but you can skip this part because we are okay, the domain is not mentioned, so we can still consider this. And at 2, what is happening? There is a shift. At 2, the value is 2. But then beyond 2, the function is changing. Beyond 2, the function is becoming as the
differentiability. Okay. Okay. So in general, what you mean by differentiability? Can someone tell me?
Slope of the tangent.
Huh?
Slope of the
tangent.
Okay. Instantaneous.
That is derivative, right? Slope of the tangent.
Means
instantaneous
direction.
At a given point in a graph,
one by
it
one
gives the ability to like look at and say like the difference in input, how much difference in input will cause the difference in output.
Instantaneous direction.
Differentiability at any point means that tangent can be drawn at that point.
Whether a tangent can be drawn at that point or not. Yeah. So basically what we are doing, suppose I have a function like this. Okay. So I want to see whether at this point this function is differentiable or not. So I am tracing the tangent at each point. Tracing the tangent at each point from this left hand side of the point and also from the right hand side of the point. I am tracing the tangent. If at this point that tangent from both sides, the slope of the tangent matches, then we can say that at that point that is the tangent, right? If the slope does not match at that point, then we can say that there is no tangent, right? Suppose, so the great example will be mod of x. So this is mod of x look like, right? So when we are coming from the left side of 0, at each point the slope of the tangent is nothing by this thing, this angle itself. The tangent is nothing but this line itself. And when we are approaching from the right side, the tangent is nothing but this straight line itself. So at this 0, the slope does not matches, right? So at 0, this function is not differentiable. That is the idea behind differentiability. Is it clear? So whenever there is some sharp turn of that curve, sharp corner at that point, then we can say that function is not differentiable at that point. Is it clear? I mean, geometrically, this is the idea. Is it clear?
Yes, sir.
Yeah. Yes, sir. So, and the definition is basically what we are giving here. So let me take this.
Sir?
Yeah.
I mean, you just said that at x equal to 0, the slope of both both sides are changing. So it is not differentiable at x equal to 0.
Exactly.
So can we say that in case of a sharp turn, it is basically a point and we cannot differentiate a point, so it is not differentiable.
We are not differentiating any point. We are checking that the function is differentiable at that point or not.
Yeah, I mean, in case of the dot function at x equal to 0, the graph is taking a sharp turn. Right? So basically, I mean that at that point x equal to 0, it is, I mean, how can I say it? It is turning towards a point. So I mean, in rest of the case, it is a line, and in that position, it is turning towards a point. So cannot differentiate the point.
Then how can you explain this thing?
So basically, if at a point two tangents exist, then that point is not differentiable. That we can say.
Basically, at that point, the tangent does not exist at all. That is the main geometric inference. At the point, the tangent does not exist. On the left hand side, there is some tangent which exists, and the right hand side, there is some tangent which exists, but the slope does not matches.
Okay.
So that's why the limit definition of differentiability will come. I will tell right now. Okay.
So basically, if we move even the slightest from that point, the slope changes entirely for that point.
Exactly. So that's is what I am going to do. And suppose this is x equal to a, I am taking this as some change in this. So this is x equal to a plus h. I am taking some change in this interval. Okay. So how the functional value changes? So here it is f of a, and at this point it is f of a plus h, right? So this length is h, right? And this length is f of a plus h minus fa, right? So if I am considering this perpendicular by base thing, which is nothing but the slope, right? Tan of that thing, right? If this angle is theta, then this is tan theta, right? Is it clear? This is tan theta.
Yes, sir.
Yeah.
Yes, sir.
So now what we are doing, we are making this h as small as possible. Basically, we are coming closer to this fa, right? From the right hand side. So if we come from the right hand side, we take h tending to 0 plus. We are taking h as small as possible. So we are coming towards this fa, and we are calculating this slope, right? This is the slope, and we are calculating that slope. So this is from right side, and similarly we have to do from left side also. The same thing, 0 minus, the formula will be same, perpendicular by base. So this is slope from the right side, and this is slope from the left side. If these two slope matches, if these two are equal, then we can say that this function is differentiable at that point. Is it clear? This is the geometric idea behind this differentiability. So if these two are equal, that means this limit exists, which is nothing but the slope at that point. So this is the derivative of the function at that point.
And this you must have heard 1,000 times in the course, that differentiability implies continuity. This again is a different, like there is a certain difference with respect to multivariable calculus. So with respect to one variable calculus, differentiability implies continuity, but continuity need not imply differentiability. So you would have seen a lot of examples for that also. Looking at the graph of a function, there shouldn't be any sharp turn at any point. If there is a sharp turn, it means that the function is not differentiable at that point, because the slope will like suddenly change from this point to this point. So yeah, so this function is not differentiable at the point 1. Otherwise, it is differentiable everywhere else. So differentiability is something you can think of like smoothness, just like continuity, how you you can draw it at one go, that is continuous. For differentiability, it is something like smoothness. So here it is not smooth, so the function is not continuous here. At origin, here the function is not even continuous, so it cannot be differentiable. So differentiability implies continuity means that not continuous implies not differentiable, the negation of this statement. So if the function is not even continuous at a point, you cannot talk about differentiability. Yeah. Is there anything that you want me to solve with respect to differentiability? I
No,
haven't.
no.
Yeah, because limits and all that, so you just know how to do it.
Hello, ma'am.
Yeah.
What is meant by piecewise continuous function?
Piecewise continuous function means the function is continuous in pieces, basically, literally speaking.
Can you give one example?
Yeah. So this is an example of a piecewise continuous function. So in this interval, the function is continuous. At this point, it is not continuous. There is a jump discontinuity. So for a piecewise continuous function, it is necessary that the left hand and the right hand limit exist, but they need not be equal. So here there is a jump discontinuity. The left hand limit exists, right hand limit exists, but they are not equal. Again, if you split in this interval, again the function is continuous in this interval. Here again there is a jump discontinuity. And in this interval, the function is continuous. Again, at this point, there is a jump discontinuity. So this is called a piecewise continuous function.
Ma'am, so in piecewise continuous function, the function as a whole is not continuous, but from a given range, from x equal to something to x equal to another thing, a given range, it is continuous.
Yes. So this is a continuous function, like, okay, this is a continuous function, but the same function, if I split it, then this is piecewise continuous.
Okay.
In pieces, it is continuous. Yeah. Okay. So yeah, same like continuity for differentiability. Also, we have all those properties of addition, subtraction, product, composition, and all that. So for the composition, means derivative of the composition. That is nothing but what you must be knowing as the chain rule. So f of g of x, this is nothing but f composite g, right? F composite g of x is nothing but f of g of x. The derivative of that composition is f dash at g of x into g dash of x. So this is called implicit differentiation. So you differentiate f at g of x, and then you again differentiate g at x. So this is the chain rule that has to be applied. So there was one question in the quiz which I remember based on this chain rule, and most of you hadn't answered it correctly. You had just differentiated f and g. So that's not how it works. You need to differentiate f at g of x, and then I found that some of you had left out differentiating g of x. So you need to differentiate g again, g dash of x. So this is the chain rule. You should be careful when you're doing this.
Ma'am, please do explain this rule some more. I think people still don't have a good idea about this. Please,
Okay.
I think you'll show some examples and be helpful.
Yeah. We had seen f composite g initially, right? I'll try to differentiate that only. Okay, I don't think that will be much helpful. So let me give an example here. So if I have f of x is equal to sine x and g of x is equal to 2x. So what will f composite g be? F composite g of x,
Sine 2x.
both domain and, yeah, it will be sine, okay, f of 2x, that is nothing but sine 2x. So this is nothing but f of g of x. So when you have to find the derivative of this composition, what you should do is f dash of g of x into g dash of x. So f dash of g of x, that is the derivative of this, that will be cos 2x into g dash of x. G of x is 2x. So you'll have an into 2 here. So this will be 2 times cos 2x. Similarly, if I do g composite f, g composite f of x will be g of f of x. So that is 2 sine x. Okay, that's not going to make any difference. Differentiating this is easy, but I'm sure that using this example, you would have understood what this chain rule means. So you're doing it in, like, there is something that is coming after what you have done the first step. So you're differentiating f at the point g of x, and then again differentiating g with respect to x. Okay, let me see if I have added any example. Okay, this one you can do, right? It's just sum of some nice functions differentiated each term, like you are just applying the sum rule, like f plus g dash is f dash plus g dash. You just need to apply that rule and find the derivative for this. I think I have given an example for implicit differentiation. Yeah. Okay. So f of x is g of x squared plus 5x. So what is f dash of x? Can someone tell me?
G f dash of x is
g dash of x squared plus 5x into 2x plus 5.
Yeah, exactly. So you need to do g dash at that point, and then you need to differentiate what is inside that, like x squared plus 5x needs to be differentiated. So this is what, this is basically f of f dash of g of x into g dash of x. So that this is not just x, this is another function x squared plus 5x. So you need to differentiate that too. Okay, so this when you find derivatives here, you need to do the second differentiation, which most of you had not done. So this is basically the chain rule, and this part I guess you must be able to do it. Just the differentiation is difficult. Okay, then what else do you know about? Yeah. And then there are derivatives of certain functions. These are all simple functions, and I'm sure that by now you must be knowing the derivatives of all these functions. Let's just skip this and go to the L'Hopital's rule. So by indeterminate limits, do you know what an indeterminate limit is?
Yes, ma'am.
Ma'am, 0 by 0, infinity by infinity, all those forms.
Yeah, all those forms, 0 power 0, infinity power infinity, 0 by 0, infinity by infinity. I guess you'll in this course you'll be seeing only 0 by 0 and infinity by infinity types. So all those are indeterminate
Power
forms.
infinity is not an indeterminate form. Like infinity to the power infinity.
Is it not indeterminate?
Yeah, I believe.
Infinity to the power 0 is indeterminate.
Oh,
yeah.
infinity power infinity is not, is it?
Yeah, it's determinate. Like it will be.
Okay, okay. I don't remember. Okay, if it's not indeterminate, then it's fine. Okay, so this, yeah.
E to the power 2x, we also use in that question the chain rule to derivate it.
Yeah. So e power 2x, how will you differentiate? The derivative of this is e power 2x into 2, right?
Yep.
So basically, yeah,
2e
basically
2x.
you're differentiating e power x, something of the form e power x. So that is why you get e power 2, like whatever it is, you get it again. And then whatever is in the power needs to be differentiated again. So this is like f of
G of x.
2x, yeah. This is g of x, and f of x is nothing but e power x. So this 2x needs to be differentiated again.
Ma'am, if there something complicated given on the power, so we can do this thing only, right? Like log or something.
Yeah, you have to. Yeah, you have to do this only. This is how you apply the chain rule.
Thank you.
Ma'am, could you please show us how you could do this 1 by 2x whole to the power of x?
1 by 2x power x.
Yes.
You can convert it into exponential, like
Yeah.
e to power ln 1 by 2x power x. 1 by 2x to power x, and that x will come outside ln, and then we can easily differentiate.
Yeah. So now you have e power something. So again, e power, this term will be there, and then you need to differentiate this. For this, you have to apply product rule, right? Fg derivative is f dash g plus fg dash. Okay, fine. So yeah, is it fine?
Yes, ma'am. Thanks.
Yeah. Okay. So when you have indeterminate forms, you must. This is the rule that comes in handy to evaluate limits. So there are certain conditions that need to hold. Only then you can apply this rule, the L'Hopital's rule. So what is it? F dash and g dash should firstly exist in the interval containing that point at which we are evaluating the limit. Then g dash of x should not be equal to 0 because you're dividing by 0 means you're dividing by g dash. So that has to be non-zero in that interval that we are considering. And limit of f dash plus f dash by g dash should be equal to L. So basically what you do is when you have limit as x tends to infinity f of x by g of x as an indeterminate form, you do this x by limit as x tends to infinity f dash by g dash. Whatever is the limit that you get for that, that is the limit for the original question that you started with. So for that, basically what is needed is that the derivative should exist around that point A, and g dash of x should be non-zero in that interval of consideration. So this also you would have done a lot of problems
here, like,
applying.
just can I boss, like, here we have also assumed condition of like fx and gx to be continuous, and like some things to be continuous. Could you just tell me that what are the conditions, like, to check whether that what should be continuous? Like
Can you repeat? I did not understand.
I said that, like, in this L hospital rules, there is condition like this La hospital rule. There is condition that like f dash x or g dash x should be continuous, like something like continuous condition is there. Like, can you just explain that portion?
So f dash and g dash should exist in an interval implies that the function should be continuous, right? Only then, like, differentiability implies continuity, right?
At that point, or like in the interval?
In the interval containing the point, like not at that point. Okay. So that's what it's written here, except possibly at A. The derivative need not exist at A, but it should exist at a point around A.
Good.
Yeah.
Ma'am, one last request.
Yeah.
Can you please move a bit down? There was one problem which you solved, this problem.
The log problem?
No, 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 no. This
one.
problem. Could you please solve it, ma'am? I'm a little confused.
Okay, fine. So f and is it the chain rule that is confusing?
No, no. I'm confused on how to proceed after this. F dash g of x.
Okay. So now we have f dash of x is equal to g dash of x squared plus 5x into 2x plus 5. So and f dash of 0 is given to be 10. You need to find g dash of 0. Find the value of g dash of 0. Okay. So f dash of 0 is equal to g dash of, so x should be equal to 0. So 0 plus 0. So this is 0.
Okay, I understood. Okay.
Yeah. So this will be into 5. So you just need to divide.
Okay. Thank you.
Okay. Okay. So this implicit differentiation, that is chain rule. You need to be careful when you're applying the chain rule. Okay. So now that we know derivatives, we are now ready to talk about tangents. So the slope of a curve at a point is nothing but the derivative at that point. So we already know what a tangent is and all that. So the equation of the tangent plane is nothing but this. So given a curve f of x, a function f of x, if it is differentiable at A, then you can define the tangent at that point. And the equation of the tangent line is nothing but y is equal to f dash of A into x minus A plus f of A. So if the tangent exists, then yeah, it means that the function is differentiable and the equation of the tangent is this. So when does the tangent not exist? When the function is not differentiable at a point, then the tangent does not exist.